All right. So hopefully you've already looked at how to multiply with negative numbers, which was a video that's above on the OneNote. So if you haven't checked that out yet, I would recommend checking that out first. Now we're going to look at how to do integers that have a power. So we're talking about like squared, cubed, and anything larger than that. We're pretty much going to focus on just squared and cubed though. We're also going to look at doing the square root, which is basically the opposite approach to squaring a number. We're going to take the square root of integers as well. And our big focus number for today is the number 7, lucky number 7. So what we're going to do first is we're going to say, okay, well, let's start with 7 squared. Now, we say squared because it's 2, meaning 2-dimensional, just like a square. So we're going to go 7 squared, and we would try and see what sort of number that would be. So 7 squared firstly means 7 times itself. How many times? It times itself twice. So 7 times 7. And if you know your multiplication all right, that is 49. That's just understanding what a squared number does. We need to think about what happens if our squared number was not really just 7, it was -7 instead, and all of that stuff is squared. Well, in that case, we would have something a little bit different. Since we know what 7 squared meant, which is 7 times 7, the same approach happens to be the same when you've got a negative number. So if I've got -7 squared, it means -7 times itself twice. So -7 times -7. And this is where we come back to our rules of multiplying negative integers. We'd approach it normally and say 7 times 7 is 49. Negatives are powerful, so a negative cancels out the other negative, so you're left with positive number. So we're left with positive 49. So exactly the same answer as 7 squared, which is fine. -7 times -7 is 49, and 7 times 7, both positives, also 49. That's going to help us when we start doing a square root of integers. So we'll do square root of integers first, and then we'll come back to having cube numbers. So when we're doing square root of integers, it's basically taking the opposite approach. So it's kind of like where plus and where addition and subtraction are opposites, multiply and division are opposites, and squaring and square roots are also opposites. So in this, we're going to say, I'm starting at 49, I'm going to work my way backwards to try and get to 7. So if I do square root of 49, it's saying what 2 numbers multiplied together or multiplied by themselves are 49. And that's where we'd have to rack our brains of what our squared numbers are. So we've got numbers like square root of 4, square root of 1 first, square root of 1, square root of 4, square root of 9, square root of 16, 25, 36, 49, 64, 81, and 100. They're the main ones that we focus on. That just means a number times itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So if we saw something like square root of 49, we say, well, where did we start? We must have started back at 7. 7 times 7 is 49. So 7 times itself is 49. Only problem is we know now that -7 times itself is also positive 49. So we've actually got 2 answers that come out. We have positive 7 or, so we'll write a little or, we have -7. Both of those answers are right. Both of them multiplied by themselves would be positive 49. So 7 times by positive 7 is 49, and -7 times -7 is 49. We don't usually show it in that sort of notation though. So I'm going to get rid of this, and I'm going to say a positive or a negative version of 7 is the right answer to the square root of 49. So we would notate it like that. Plus or minus 7 would be the answer to square root of 49. So before we go, let's have a bit of a look at what happens when we don't have a squared. What happens if we have a cubed instead? So cubed, because 3 dimensions is a cube, and to the power of 3 must mean that it's -7 times by itself 3 times instead of 2 times. Now, that might be something where you need to go away on a calculator. I know that 7 times 3, not 7 times 3, 7 times itself 3 times, or 7 times 7 is 49, and 49 times 7 is 343. Because 50 times 7 would be 350, and we take away another 7, and that's 343, or 49 times 7. So, the sign's the important part. Going away and doing 7 times 7 times 7 on a calculator is fine, but knowing how the negatives work is important. So I've got a negative and negative. They must cancel each other out to make a positive, because that's what we've done before. Negative 7 times negative 7 is positive 49. And I can, underneath that part, do that. That is positive 49. So we would say positive 49 times by negative 7. Well, I know that negatives are powerful, so a negative overrides the other positive and makes my answer negative. So I'd end up with negative 343. So a negative times another negative must be a negative number. And it'll keep on going like a pattern like this, where we'll have a negative number, a positive, a negative, a positive, a negative, and it'll keep going like that depending on what power you choose. If I went to the power of 4, I'd have 2 sets of negatives that cancel each other out, and I'd end up with a positive number. Try and have a go at some of these on your own on the OneNote. And if you have any trouble, let me know.